This is Safe Home, a research project we are working on to deliver mobile solutions for home safety improvement. The tour begins with a brief background introduction, followed by a review of related works. Then the main features of our application will be presented with a live demo. After that, my colleagues will give the evaluations based on the results of the performance trials. Next, several limitations of the application will be discussed. Finally, the video will be concluded with a short summary of the project. Over recent years, home injuries have become the leading cause of deaths around the world, accounting for 70% of all unintentional injury deaths. Unintentional home injuries are caused by a wide range of factors, among which the absence of appropriate home safety education tends to be the prime culprit. Although Australian government have invested large amounts of resources in facilitating home safety education, the payback was not optimistic. Therefore, our team presents an awesome application, Safe Home, which is able to help people manage potential injury risks at home. Our application has two modes. Under the detection mode, the application collects the information of the surrounding environment and examines whether the placement of certain objects can cause possible injuries. Then, the application generates a strategy to rearrange those objects to avoid the risks. Finally, under the accident simulation mode, the application uses AR technology to simulate the scene of accident caused by those risks on the mobile devices for safety educational purpose.
This part is the related works of our application. We used mainly three technologies in our mobile application, including 3D modeling by making use of videos or pictures, object detection, as well as augmented reality. These three technologies are widely used in safety domain. According to previous works and applications, 3D modeling is used in home design, architecture, and building industry to make sure the design is safe. Object detection is used in traffic lights and foodstuff. For example, to recognize whether a plant can be eaten. And augmented reality is used in life support training and learning support for earthquake by simulating a real situation. We take a further step and combine these technologies creatively to achieve a safer home, including identifying potential threats, providing advice for home layouts, and simulating the threat consequence. This part is a prototype and a demo of our application. As you can see, firstly, we launched our application and shooted a video to capture room layouts. Then, we edited this video. And uploaded it to the server. After waiting for some time, we got the feedback. The feedback includes a 3D model of the room. Some detected potential risks. As well as layout advice. Due to the privacy reason, we are not allowed to show the AR effect of these potential risks, as it includes the use of real home scenes.
Let me introduce how we evaluate our system. We invited 5 people to experiment our application. 4 of them were careless people who did not pay much attention to details, while the other one cleaned her house frequently and had a strong sense of home safety. The trial was designed to test how long our system actually took to return feedback to end users and how effective our advice could be. To ensure that the evaluation process was under control and the results were accurate, we assigned each candidate one of our professional employees to guide them during the process. Here shows the results of processing time for each user before they got the feedback. As you can see, the amount of time for users to wait was around 5 to 6 minutes, and the only exception was for user 4 because of his duplex health structure, which was more complicated for analysis. Here shows the results of the questionnaire after users finished their trial. The first 4 questions were close-ended, and as is shown by the charts, all average scores were larger than or equal to 4, indicating that users, on the whole, were satisfied with the performance of our system. The last question was an open-ended one. From users' answers to this question, we conclude that there are mainly 3 flaws in our application. The first 2 will be detailed in the next section talking about limitations. The third one means that our system helped little to those who have strong safety awareness at home, which may actually be the case in terms of our target users.
There are several limitations of our application. Firstly, inaccurate object recognition and lack of search knowledge may result in the detection of non-existent risks. By the way, our application cannot tell you whether there is a bump in the box or not. Another limitation is that our application is not applicable to disaster situations. In fact, our original prototype considered implementing functionalities that could generate the optimal survival guide under disaster situations, such as earthquake and building fire. However, due to the financial and technological reasons, this feature was held as a possibility for the future improvement. Finally, privacy issues are inevitable. On one hand, users may feel unsafe to upload their home environment to a server at risk of personal information leakage. On the other hand, we cannot forbid users to shoot and upload a video of a military base, which may lead to serious legal issues. In conclusion, we presented a well-designed fictional mobile application for enabling active decision-making in the daily life. Our application employs a specially designed search strategy and is able to detect and remove hazards at home. Future studies should focus on addressing the limitations mentioned above and also integrating new technologies. Thank you for watching.